Okay, I think we'll get this session underway. So hello, everyone. Thanks for joining. Thanks for your interest in JMAG. And so my name is Brian Kowalczyk from PowerSys, and welcome to this session about drive cycle analysis using JMAG. So in this session, you're going to see a presentation from PowerSys, and then also followed by a presentation from Tula Technology. So please note we're going to do the Q&A session after both presentations are done. So first, we're going to hear from my colleague, Simon Chu, who's one of our JMAG technical experts at PowerSys. And Simon received her master's degree from the University of Wisconsin-Madison in 2007. From 2008 to 2018, she worked as a motor design engineer and motor calibration engineer at General Motors. And she is a senior motor design and application engineer at PowerSys Solutions since 2018. Her research interests include the design, analysis, and testing of electrical machines. So with that, Simon, I'd like to welcome you to share your presentation.
Thank you, Brian, for your introduction. Hi, everyone. Let me start with a presentation. So today we're going to talk about drive cycle analysis using JMAG and efficiency maps. And drive cycle analysis are critical for motor design selections, as we all know. And ideally, we want to generate accurate maps as fast as possible. In JMAG, you are capable of creating two types of efficiency maps that are specifically designed for speed and accuracy. Also, for both types of efficiency maps, we are able to add drive cycle points and evaluate average efficiency and total energy consumption so that the selected machine design is the most efficient for the drive cycle points. The efficiency maps will be session will be divided into three parts. The first one is the speed priority efficiency map. As a general introduction is because it's a speed priority, we consider speed as the first priority. It is fast and can be calculated on the local workstation. Let me show a demo of it. Even though we consider speed as a first priority, that doesn't mean that we don't calculate eddy current losses, we don't calculate the stress. We can still consider quite a bit of factors in JMAG because JMAG is very considerate in that aspect. First of all, we can see that one condition is the stress distribution, which consider the shrink effect, and also in the efficiency map setup, as you can see, you have the option of switching between the EM torque and shaft torque. The shaft torque is simply the EM torque minus the losses. And then we also have the approximate PWM iron loss option that you can add this to the efficiency map. You also have the option in version 20.2 to add PWM magnet eddy current losses by defining the conductivity of the magnet material and the number of axial segment numbers and the air gap thickness. Also, we are able to add AC copper loss estimation that you can input the configuration, the location of the bars. And by that, let me quickly show the speed priority efficiency map. As you can see, the speed priority has motoring and regen two parts. And then we can change the settings. That's a quick view of the efficiency map. And then we can also add the speed priority settings, add the drive cycle settings by adding the drive cycle points. You can simply import it from the table. And then let me quickly show the drive cycle points. These are the drive cycle points, and then JMAG will calculate average efficiency on those points and total energy consumption. Then you can also show the cluster point of those drive cycle points. So that's a quick demo of the JMAG efficiency map feature. And then for accuracy priority, it is more accurate. We put more factors in there, so the simulation takes longer time to reach steady state because of the control and PWM effect. So we normally need HPC for the hardware and PSL for the JMAG software licenses. So this allows us to make accuracy priority map. Let me show you a demo of that. I won't show you the process because it takes very long time. It cannot be fit into the demo session. So I only show you the result of the accuracy priority of this machine, IPM machine with a bar winding. Of course, I considered the control circuit, and that's the efficiency map. Let me show you how the control circuit looks. So it has the PI controller, has the PWM waveform, and also important thing to note is that because the transition time is very long, JMAG allows you to put the RTT model, the JMAG RT model, to run the transient time in a very short time. And when it's very close to the steady state or reach a steady state, then you use the switch, RT to FEA switch, to switch to the real FEM conductor model, the real FEA model, so that with this FEA switch, we are able to save the time to run the transient simulation and also can consider the FEM conductor effect, which is AC effect. And with that, we can also add the drive cycle in the same way as we did for the speed priority efficiency map. And we can show the drive cycle points and also check out the average efficiency and total energy consumption. Then let's go back to the presentation. So we show the efficiency map, we show the control circuit, and now let's go back to white papers and customer in the presentations from the industry. So we are often asked how the customer can create efficiency maps, accurate efficiency maps in the shortest period of time possible. And that's why this white paper is made. You can download this white paper and customer presentation from JMAG website. And first of all, this presentation is very useful to give you the background information. How can you make accurate efficiency maps? So we start from a speed priority model, and we consider all the factors. For example, the PWM carrier effect on losses. So you can see this effect on loss increase, and also the AC copper loss for the loss increase, then the stress, the contribution of stress on the losses, then processing strain contribution to the losses, then eddy current of the surface of the 3D model. So both end of the rotor ending, the lamination has more higher eddy current. So if you consider that, it also reduces your error between the calculation simulation results and the measurement. Finally, we need to consider the minor loop in the loss calculation, iron loss calculation. And with all these factors considered, we're able to get 1% error in most of the operating regions. And you can see the efficiency transition from the original base model. This means the speed priority efficiency map. And after considering the PWM effect, AC copper loss, so the efficiency map efficiency values are lower and lower and lower and lower and lower. So finally, with all these factors considered, you can see that it matches the measured efficiency map. So that's a process you will go through if you really want to reduce the error of the efficiency map and the real measured values. This is an example from the NEDEC. NEDEC basically goes through the same process. It's a presentation from User Conference 2019, and it has considered the AC copper loss and consider the residual strain. You can look at the details after downloading. And residual strain, I just want to quickly go through what is considered to make a more accurate, very accurate efficiency map. And the PWM effect is one we have to consider. And then finally, the efficiency map was plotted. It plot by points. It's not a smooth with integration, but you can see it's within 1% error in 70% of the efficiency map region. It's very accurate. Then we also have a presentation from 2020 last year. It's about the highlight of this presentation is that it's not a traditional three-phase machine, it's a dual three-phase machine. So JMAG is capable of calculating not only the traditional PMSM or induction machine, it also allows you to quickly create dual three-phase PMSM. It was very helpful for you to save time to set up and create your own code. So the existing efficiency map tool just facilitated the process and save time for you. And you can see they developed the control part and build that within JMAG and feed-forward part with all these controls. And they create speed priority without the controls, just sinusoidal current as the initial step. Then for this dual three-phase PMSM model, later they add all these controls and consider the current harmonics and feed-forward control and generate accurate efficiency map for such dual-phase, three-phase PMSM machine. So in the last step, a drive cycle analysis has been done for such design, motor design, and you can see you can calculate the power consumption, which is very helpful to for motor design. It's optimized to reduce the power consumption. It's very important for the machine design. And then, so that is the presentation from Mercedes. And actually, that wraps up my presentation.